So that we discuss the infeasibility coming from the finite state machine and cellular automata. And there is one formula that fills in such kind of insufficiency with internal state transition, named DEVS formalism. Okay? Here, DEVS formalism means means discrete event system specification. And this DEVS formalism is being introduced by the B.P. Ziegler. Okay? He recently retired. And from the simulation world, it is a formalism to model and simulate a discrete event system. I want to add up here from object-oriented perspective. Okay? So the non-characteristic of this DEVS formalism is this. First, it has a modular and hierarchical structure. What's the benefit of being modular? And what's the benefit of being hierarchical? Means that we can do divide and conquer. Do you remember binary search tree or binary tree in your data structure course? Such kind of tree structure is the first time that you will encounter divide and conquer approach in data structure. Linked list, we cannot do that. So that this divide and conquer provides us some efficiency in searching values and so forth, right? And here, same thing. Being modular and being hierarchical like a tree structure provides us a benefit of divide and conquer. Also, this DEVS formalism needs to have a certain basis, and that basis is the finite state machine. So the whole discussion done in the finite state machine, except the expanded part by the DEVS formalism, still applies. Okay? Only this DEVS formalism expands the previous finite state machine formalism. So that once finite state machines are being utilized in many different fields, DEVS formalism can be a superset that encompasses all the finite state machine, and so that DEVS formalism can be also universal. Here, DEVS formalism is for the discrete event system. It's not a discrete time system. Discrete time system is like a digital system with a preset cycle of time step. 1, 2, 3, 4, 5 time step. Din, 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 din. Regular intervals of time. That's the discrete time digital system. On the other hand, discrete event system, this follows what? The continuous time. This is being continuous, and any given time, event 1 happens, event 2 happens, event 3 happens, event 4 happens, and so forth. So that discrete event system specifies the event at any given moment, and at any given moment, event will change what? The state. So time will be controlled by the continuous time-defined event, and that event occurrence make the state being changed discretely. This DEVS formalism has been utilized in many different fields: modeling hardware, software, sociology, biology, manufacturing system, military system, and so forth. All of these widely used. It consists of first the atomic model, and this atomic model is really fundamental basis of creating a DEVS model. Okay, and we are going to look into that later. And this atomic model can be explained by this diagram. Atomic model has what? Atomic model has two delta functions, meaning delta internal state transition, delta external, ext, delta external state transition functions. And also lambda, meaning linked to the y output function. We have state variable and also time advance function. Okay, so each state will create time advance. Each state will create a time advance. Each state will be projected to the outside variable. And there will be external transition or internal transition. And that particular internal transition will be linked to the time advance. Right? That's the atomic model. We are going to discuss this further details. And coupled model is being here. This coupled models is what? It can couple two different models, two different depth models. Two different depth models and create a new model. Composing multiple atomic models, or it doesn't have to be an atomic model. If it is being a depth formalism model, closed under coupling, then it will be composed by coupling the models. For example, we have a model of A, B, and C. And A, B are being depth formalism model, having X input, Y output, X input, Y output of AB model. Then what we can do is that we can just feed in X and get the intermediate result, and get the intermediate result fed into the B, and we get the output Y. And we can just say this system is AB, input X and output Y. Even we can couple A, B, and C, so we can create one big model of ABC. So that's the depth formalism.